So I am going to warn you, today is going to be a little complicated. All right, this is very bizarre, and we are actually only going to scratch the surface of this. I don't feel like we need to go in depth, but I do want you to see it and then at least experience some of it before. So this is actually graphing complex numbers on coordinate plane, and how we can find some of these. And this uses some trig, which is why we had to do that lesson yesterday. So if you have a number a plus bi, okay, because remember I can't combine a and b because b has an I attached to it, they correspond to the point a and b in the plane. So for example, see if I can move this up just a little bit. Okay, good. Okay. So for example, this point right here, okay, 2 plus 3i, okay, your real number or your is your x value, your I value is your y value. So it's going to be over 2 and up 3, and that's the coordinate point that associates with it. All right. Likewise, so 5 plus 5.5. They put some of these down here just so you can kind of see what they are. 5.5, okay, has no I, so it's just 5.5 on the real number line. There's no up or down. All right. 4 minus 3i over 4 down to 3. Okay. 2i, okay. There is no real number, so it's just up 2. Negative 6 plus 2.3i, so we go negatives over negative 6 and then up 2.3. You'll notice it's just above the 2. The same thing down here, okay, negative 5 and then down to the negative square root of 3, which is about 1.7, so it's right there. So it's just kind of a different way to represent these numbers. All right, so sometimes you want to be able to find what's called the absolute value of a complex number, where we can get rid of that idea of a complex number. So this is just, in the question will very specifically say, find the absolute value of a complex number. It's very simple. So what we're going to do is we're going to actually do some problems. So the absolute value of a plus bi is the square root of a squared plus b squared. This should look familiar, okay? If you remember when we were looking for the triangles, and we had x and y, and r was the square root of x squared plus y squared. It's the same thing. So, so we're going to do this. So 3 plus 2i is this, oops, I need a color. Right. It's the square root of 3 squared plus 2 squared, which is 9 plus 4, which is the square root of 13. Okay, these numbers are going to come back up again, so we're not just doing them for the sake of doing them. Okay, 4 minus 5i is the square root of 4 squared plus 5 squared. Right. It really doesn't matter that there's a minus in there, because when we square everything, it becomes that it's irrelevant. So 16 plus 25 is the square root of 40. Okay. If you can take the square root, definitely take it. Like if the answer were the square root of 16, it would be 4. If you can't take the square root, just leave it as a root. Okay. So now, do you remember when we were dealing with, when I just told you that we dealt with the r's, the x and the y and the r's. This is another way to write a complex number. It can be written in what's called polar form. When we're dealing with trig and that kind of stuff, typically we're graphing on a polar coordinates. Okay, that's why we have to change from degrees to radians when we're dealing with trig. But we need to be able to represent a number in polar form. We're not actually going to graph any of these. You just need to be able to see it. Again, like I said, this is just kind of an introduction, just so that you've seen it before. We're not going to go real in depth in it. I almost skipped it all together, but I think it's probably something we should see at least a little bit. Okay. All right. So we're going to take this this problem right here, and we're going to express it in polar form. So the very first thing that we need to realize is that we have a's and b's. Okay. So my a here is negative square root of 3. This can also be associated with x if you think of it that way. Okay. B is 1. Okay, the number in front of I is 1 or 1. All right. So if you remember all of these pieces from when we were doing the trig formula. Okay, so we need to find r. So r is the square root of the square root of 3 squared. It's a negative square root of 3, but it's still all going to work out in the end. Plus 1 squared. Square root of 3, because the square root of 3 squared is 3, plus 1 is the square root of 4, which is 2. So in this case, r is 2. This is nice, but this works out this way. All right, now we have this side. The polar form can be written as r times cosine of theta plus I sine of theta. So what we want to know is what is the cosine and sine of theta. So the cosine of theta, you remember, is cosine is x over r. So in this case, it's the square root of 3 over 2. Alright? And the sine of theta is y over r, which is 1 over 2. Okay? So our answer can be written as 2 times, okay, so we know the cosine of theta is a negative square root of 3 over 2 plus 1/2 I. Okay. We can simplify that. Okay, sorry, I messed up. I was thinking of it in a different way. So we actually need to write it with the cosines and sines in the problem. So what we actually have to do is find out what is theta. All right. So these come from unit circle problems. Yeah, the answer has to have cosine and sine, and we need to know what theta is. So it doesn't matter that I know what cosine and sine theta are. What I need to know is what is theta, so that I can write it with the cosines and sines in my problem. I apologize. I was thinking I could do it simpler, but I can't. So what we need to know is here we have cosine is negative and sine is positive. Okay, so if you remember in the unit circle, okay, everything was positive here, all right? So all, okay, sine is positive in this quadrant, cosine is positive, tangent is positive in this and cosine is positive in that quadrant. So it's really important for us to see what quadrant it's in. So we know that since sine is positive and cosine is negative, that it must be in the second quadrant. All right, so where is cosine equal to the square root of 3 over 2 and sine equal to 1/2? So if you look at your unit circle again, or your triangles, okay, 1 square root of 3, 2. Okay, what angle is cosine root 3 over 2? So it would be this one. So this angle right here is pi over 6. Okay, we're in the second quadrant. I know this seems super complicated, okay? This is using stuff that we've learned for a while now. Okay? Pi over 6 is in this quadrant, right? Which angle is the pi over 6 in that quadrant? Okay, it is 5 pi over 6, and I know this because 1 less than 6 pi over 6 is 5 pi over 6. So my answer for this problem and how it has to be written is 2 times the cosine of 5 pi over 6 plus I sine 5 pi over 6. And that's how I have to leave it. This is considered polar form, and that's how I have to leave the problem. Okay. I don't think I put any of these on your homework because they were just a little bit too complex. So you're going to be using the rest of them, but I wanted you to see this, okay? Because I wanted to keep them in the unit circle, and I don't think any of the problems on the homework actually had unit circle. They were all more complicated, and I didn't want to put you through that. So, but we are going to go on to problems that you will see on the homework, and these use the rules that we learned with the sine and cosine addition and subtraction rules. So, moving on. And actually it's really nice because it plugs it on for you. I did it the long way the first time I did it, and then I went, oh, it already did it for me. So it gives you some new rules. Guys, all you have to do is plug in. Super easy. So it says if Z1, okay, is this complex number, and Z2 is this complex number, and we want to multiply them together, then this is how we look at that problem. If we want to divide them, then we plug into this formula here. You'll notice the r's are already given to us. The theta's are already given to us, okay? This is really not as hard as it looks, okay? We just need to plug into formulas. So, if you would like to see how it works, try doing it with your sine and cosine formulas that we learned before, and it will still work out. Okay, that's only if you really want a challenge. So, if I'm doing Z1 times Z2, I have R1 times R2. 3 times 12, okay? Then I have cosine of theta 1 plus theta 2. All right? This is theta 1. This is theta, sorry, let me point with I'm pointing in. This is theta 1, and this is theta 2. All right, so we're going to do cosine of theta 1 plus theta 2. Cosine of pi over 8 plus 3 pi over 8. Okay? And then it's plus I sine pi over 8 plus 3 pi over 8. All right, so let's think about this aside here. Some of you can do this in your head, some of you cannot. I'm doing this for those of you that can't do this in your head. Okay, pi over 8 plus 3 pi over 8 is 4 pi over 8, which is pi over 2. Now, if you know your unit circle, all right, you can go and say it's 90 degrees, okay, so it's straight up and down. All right, cosine and straight up and down is 0, and sine is 1. So this is going to be 36, okay, times cosine of pi over 2, which is 0, plus okay, I of sine pi over 2, which is 1. So it's just 36 times I, which is 36 I. And that is my answer. Okay, all I did was plug in a formula, use the information I already know. I hope you realize by now why I was trying very hard for you to get to memorize those unit circle things. Okay, if you don't know your unit circle, you're going to be lost. So, all right. Moving on, division. Okay, and this is the last example today. Okay, so division, we're going to use the division formula. Okay. So we have 8 and 4 is my R1 over R2. So 8 over 4 times. Okay, cosine, theta 1 minus theta 2. Theta 1, theta 2. Okay, so cosine, 5 pi over 18 minus pi over 9. Okay. Plus I sine of the same thing. Okay, 5 pi over 18 minus. Okay. Now, I'm going to actually do that part of the problem so that into the side for those of you that have trouble. Okay, 5 pi over 18 minus 2 pi over 18 is 3 pi over 18, which is pi over 6. So I have 2 times cosine pi over 6 plus I sine pi over 6. Okay. Cosine of pi over 6, again, if I use my triangles, okay, is radical 3 over 2. Sine of pi over 6 is 1/2, so it's I over 2. Okay, now I'm going to distribute the 2 and end up with square root of 3 plus I. All right, and that's it for your homework. I want to go back and just kind of talk about a couple of things. You're going to have problems like this. You'll have problems like this. This right here, I did not assign on the homework. Okay, I wanted you to see it. It is very complex, but I did not assign any of those on homework. And then you'll have problems like this where you have to just get the R value, essentially. So, all right, that's it.